Welcome back to the course on power plant economics. As you know, this is an important topic in energy engineering. Important because, as we had discussed in the earlier two videos, power plant is the most capital intensive structure. And how much capital intensive? We said that in today's numbers, approximately about 5 to 6 crores of rupees goes in installing a 1 megawatt power plant. And you know that the power plants, and I'll be showing some numbers today, and they are having installed capacity in thousands of megawatts. And those installed capacities you can just multiply with 5 crores as average. That amount of investment is in the power plant. So, from the engineering perspective, we need to be very judicious about designing the power plant. And in order to design and in order to understand its viability, we need to appreciate certain concepts. So that is what we were trying to do in the last two videos. A recap of what we did in the last two videos. We talked about what is called as the capital cost, which is nothing but the initial investment that goes into the power plant. And then we learned as to how do you calculate the fixed cost from the capital cost. We said that fixed cost calculation depends upon the rate of interest and the depreciation. For example, if the fixed cost is the capital cost is 5 crores, the rate of interest is 5% and the depreciation is 5%, then we arrive at the fixed cost as 10% of the capital cost. So that is the simple way of arriving at the fixed cost. And we said that the fixed cost is independent of the hours of usage, because even if you have a power plant and if you don't generate electricity out of it, you would be anyway have paying the bank the rate of interest and the plant would be anyway depreciating. It means judicious way of operating the power plant is see that the operating hours are increased so that the component of fixed cost gets reduced. The other cost which we talked about in the last video was the variable cost, and the primary component of the variable cost is the fuel cost. We are talking about the fossil fuel power plants. So the fuel cost is a critical component in the variable cost, but there are other parameters also like the operation and maintenance cost. We said that the salary of the people who are working in the power plants also matter. The maintenance cost would also be included in the variable cost, and this is a function of operating hours. So operating hours is a parameter which would influence the economics of the power plant. And to quantify the operating hours, we would be learning certain concepts in today's lecture. We said that the economics is best expressed in terms of how much rupees we need to pay per kilowatt hour of electricity generated. So the outcome of today's lecture would be you would be getting some numbers about the installed capacity and appreciate the difference between the energy generated and installed capacity. I will show you some numbers of Indian power sector in this video. Then we would be learning certain concepts and important concepts like uh, PLF, which is nothing but plant load factor. Then you would be learning what is known as the plant capacity factor and also what is known as the usage factor, plant use factor. So all these parameters they are frequently used in power plants, and it's a good idea to appreciate what they mean. You would also see a typical load curve and how this load curve influences these parameters. So to get you the feel of the power plants in India, I had displayed here on the on your screen the quite recent data of the installed capacity in megawatts, and this data is for 2018. If you look at the numbers, it's a very interesting thing. You see that the thermal power plants, they are the major power plants, and they contribute to about 65% in terms of installed capacity. Of this thermal, the major component, and you must be knowing this, comes from coal. So the coal is about 57%, the gas is 7%, this 65%, this 57 plus 7 is approximately 65. There are some other some minor thermal contributors. So in the installed capacity in megawatts in Indian power sector, thermal is a major parameter which is contributing to the power mix. The other major uh, parameter or other major type of power plant which is contributing to the power mix is, if you look at the numbers, after thermal comes renewables. So renewables is approximately 70,000 megawatts contribution in terms of installed capacity. Followed by renewables, it is hydro which is coming third, which is contributing about 45,000 megawatts. I'm talking about the national picture. And finally, nuclear, which is a minor contribution in terms of 2%. So if you rank them, rank these power plants in terms of installed capacity, so the coal would be first, followed by renewables, third would be hydro, fourth would be gas, and fifth would be nuclear. So these are the major power plants. Now, in order to appreciate the difference between the installed capacity and energy, I would raise a simple question. But before that, one more interesting data I just wanted to share, especially because we talk about um, what how the development has happened since independence. So if you look at the numbers, the installed capacity when India became independent, that was around 1700 megawatts. It's quite a small number as compared to what installed capacity we have right now. So you see the growth, the rate of growth of the installed capacity. So today we have grown 130 times what we were in 1947. So it is quite a good achievement. And even if you look at this numbers, for example, in 1947, only 0.5% of the villages were electrified. That is negligible. It means that almost all the villages were in dark. Okay, and only few major cities and towns had electricity, and that too only few houses of those major cities and towns or few industries of those major cities and towns were electrified. And about 45% of the electricity it came from the private utilities. And this is what was in 1947 when we just got independence. uh, so again, to appreciate between the difference between energy and installed capacity, uh, we said we talked about the ranks. In terms of installed capacity, the first rank goes to coal and the last rank goes to nuclear. Now the coal is contributing 57% in terms of installed capacity. I put a question mark over here. So I'm just asking you whether coal would be ranked number one. That is the first question. And second is, what would be the contribution in terms of energy? Whether the energy contribution would also be 57%, or it would be more, or it would be less. You just compare this to coal and renewables. So if this is 57%, what would be this number? Whether it would be greater than 57 or less than 57? If this is 20%, what would be this number? Whether it would be greater than 20 or less than 20? Think over it. If you think over it carefully, you'll understand that basically this renewables, because of the uh, because of the inherent property of renewables, that it has a time limit when this energy is available. For example, solar is available only for few hours a day, whereas there is no intrinsic limit in this fossil fuel based power plants. So you'll find that the energy from the coal based power plant, it would be greater than 57%. So this question mark would be replaced by a number which would be significantly greater than 57%, whereas though the installed capacity of renewables is 20%, in terms of energy, if you look at the numbers, and this is an assignment for you, you can just plot the rank and the contribution of this five major power plants in terms of energy. So you'll find that the contribution of renewables would be quite less. The reason is, for example, renewables, wind or solar, they would be available for only few hours a year as compared to coal or some other or nuclear, for example, for which would be in operation for about 8,000 to 8,760 hours per year. Okay, so this is the difference, and this difference, if you want to understand, then we need to have certain parameter which would explain that. So before that, I would just want you to look at this figure. This is the typical load curve which I have drawn, and this load curve gives you a good understanding about what is the load on the power plant. So any power plant, if you consider, there would be some zigzag pattern of the demand which goes into it. Okay, so the zigzag pattern would depend on many parameters. Okay, if this is a daily load curve, for example, then you'd find that in some hours of the day, the demand would be maximum. If it is a monthly load curve, so you might find that some days of the month, the demand would be maximum, and in some other days, the demand would be minimum. If this is an annual time of the year, okay, then also you might find some seasons, for example, where the demand is higher and some seasons where the demand is lower. Okay, for example, if you are talking about agricultural load, you will find that the agricultural load is minimum in rainy season because the pumping requirement is less there, whereas the power demand would be maximum during summer because there you have to pump more water for irrigation. So this is the significance of load curve. So the load curve is basically on the y-axis you have load, which is in megawatts, and in the x-axis you have time in hours. For the annual load curve, this time would be 8760 hours. For a monthly load curve, it would be 30 into 24 hours, and for the daily load curve, it would be 24 hours. This dotted line shows the average demand. So there's a mathematical thing. We need to calculate what is the average demand, and this would be the maximum demand. This would be the maximum demand. So understanding what is the average demand, what is the maximum demand would influence the choice of the power plant, and it would also influence the economics of the power plant. Okay. The area enclosed by this load curve would be obviously megawatt hours if this is in megawatt, or kilowatt hours if this is in kilowatts. Okay, so the area under this would be megawatt into hours or kilowatt into hours. So this area is nothing but the energy or electricity which is generated, whereas this y-axis is the load or the installed capacity which we are talking about. So this we have to appreciate well. So in order to appreciate this, there are three parameters which you must understand. One is the plant load factor, other is the use factor, and third is the capacity factor. So what is plant load factor? So the plant load factor is nothing but its ratio of the actual energy which is being generated by the power plant to the maximum energy which one can generate, right? So this plant load factor, it can be expressed in terms of load also. So the average load, the actual load upon the maximum load or the maximum demand. Okay, so this is called as a plant load factor. So average load, as we had seen in this figure, this is the average load and this is the maximum load. So this average load upon the maximum load is the plant load factor. Then what is the plant capacity factor? Okay, plant capacity factor is the average load upon plant capacity. So look at these two numbers, average load upon plant capacity and average load upon maximum demand. So how are they different? How is the plant load factor different from plant capacity factor? So if you look at these two equations, you'll find that the equation is different in terms of denominator. So in the plant load factor, you'll find that the denominator is maximum demand, whereas in the plant capacity factor, the denominator is plant capacity. Now, if you look at this figure, it might happen that the plant, let us say this is 100 megawatt plant, and 100 megawatt is somewhere here, 100 megawatt is somewhere here, and the maximum demand is, let us say, 90 megawatts. So let us say 90 megawatt is somewhere here and 100 megawatt is somewhere here. So then in this case, the plant load factor and plant capacity factor would be different, right? Suppose the average demand is 50 megawatt. So the plant load factor would be 50 upon the maximum demand, which is 90. So 50 upon 90 is the plant load factor, whereas the plant capacity factor would be 50 upon this 100, which is the capacity of the plant. Suppose the capacity and the maximum load happens to be the same. So suppose the plant is of 100 megawatt capacity and the maximum demand is also 100 megawatt. So in that case, it is but obvious that the plant capacity factor and the plant load factor, they would be the same. So when the plant capacity is equal to maximum demand, the PCF, that is the plant capacity factor, is the plant load factor. So the typical value for the plant capacity factor for the wind power plant is about 20 to 40%, and that is what I was talking about, that renewables, they have a lower plant capacity factors, and if it is a coal based power plants, then the plant load factor is greater than 70%. It could be theoretically 100% also. So this you need to appreciate, and this would decide what is the electricity which is actually generated by these power plants. So the installed capacity is one thing and the electricity generated is altogether different thing. There is third parameter which is also equally important, which is known as the use factor. So the use factor, how do you calculate? So the use factor is the plant capacity factor into, and I'm talking about the annual use factor. So the annual hours in a year, you know that there are about 8760 hours upon the annual use hours. So actual hours of usage. Some plant might be in operation only for, let us say, 6000 hours. So let us say some plant is in operation for 6000 hours, and then how do you calculate the use factor? So what you do is that you first calculate the average load upon plant capacity and then multiply it with the theoretically maximum hours. For example, in a year there are 8760 hours upon the annual use hours. Suppose the plant was in operation for 6000 hours. So 8760 upon 6000 into PCF would give you the use factor. So these three important parameters you need to understand. One is the plant load factor, which is nothing but the average demand upon maximum demand, the plant capacity factor, which is nothing but average load upon plant capacity, and plant use factor, which would account for the actual usage hours. Actual usage hours. So this is one numerical which is given as a homework. You must try this in order to appreciate what concepts we have learned. So suppose we consider some thermal power plant of a 210 megawatt capacity, and this 210 megawatt capacity power plant has a maximum load of only 160 megawatt. So how do you calculate the plant load factor? How do you calculate the capacity factor? And how do you calculate the cost per unit? Right? So the plant load factor, as we said, is average load upon maximum load. Right? And suppose the some number is given for that plant load factor, from which you can calculate the average load, or you can calculate the capacity factor as the average load upon capacity. So these are the answers which are given. So try doing this. The economics part also is included in this. So whatever you have learned in the first two videos, that and whatever you have learned in this video, that would be tested by attempting this problem. So best of luck for solving this problem. Thank you very much.